In this video, we're going to build a machine learning app in pure Python using Streamlit. And so without further ado, let's get started. So the first thing that we want to do here is you want to make sure that you have GitHub account ready to go and also a Streamlit Cloud account. So both of them are free. And so go ahead and sign up, pause the video first, sign up for it, and then proceed further. All right, and so let's say that you have already signed up for your GitHub account and for your Streamlit Community Cloud account. It's also free, so you could sign up here. And so I have already done so I'm going to sign in. Click on Continue to sign in. And then I'm going to use my Google account, which you could also do the same as well. Or you could also use your email as well. And it's going to ask you to allow authentication to your GitHub account. So you could go ahead and do that as well. All right, and so now we're inside the Streamlit Community Cloud. And what we want to do first is we're going to head over to the Streamlit repository. And we could search for it here. And then search for the App Starter Kit. So it's here, Streamlit App Starter Kit. So this is the starter code that you could use to quickly spin up a Streamlit app. And so in only a few seconds, you have an app up and running. So we're going to click here, use this template, create a new repository, and then we're going to give it a name. So why don't I give it the initial of DP, which is for data professor, and then machine learning. I'll make it public. Click on the create repository. Give it a few seconds. All right, so this is the repository for our app. So why don't we get started by modifying the README information here. We're going to call it machine learning app. I'm going to make this a robot emoji. Then I'm going to just, this is a machine learning app. Okay, and that's all. That's all for now. Okay, I might as well modify the URL here to dp-machine learning, which we're going to use shortly. And then we're going to save it. And then we could come back and modify the remainder of the contents in here. So go back to the main repo here. In the requirements.txt, we're going to add in our dependencies. So I'm going to leave it as Streamlit so that it updates to the newest version. I'm going to have numpy. I'm going to have pandas. And we're going to use scikit-learn, right? Because when we're building machine learning models here, we're going to use scikit-learn to build the machine learning model. We're going to use pandas for importing the data. We're going to wrangle the data using pandas. And we're also going to use numpy for numerical processing. So we'll go ahead and update this requirements.txt file, which is the equivalent of installing, Python libraries on your computer using like pip install, the name of the library. And then this is our app. So why don't we go ahead and deploy the app? So I think I can close this. And once you're already logged in to the Streamlit Community Cloud, you want to click on Create App. And we're given two options here. Go ahead and click on the Yup, I have an app on the left. And then we're going to put in the name of the repo that we have just created, which is dp-machine learning. That way. GitHub account name there. Okay, and everything is detected to be true here. I'm just going to delete the last part of the URL here. And we're calling it dp-machine learning, okay? And so the domain is available. So you could feel free to name it anything else that you like here as well. Like having your name in front, because generic names might have already been taken. So click on deploy. And so it's worthy to note here while we're deploying the app that you could create and deploy unlimited public apps for free, and that you could also, if there's a need to, you could deploy one private app as well. All right, and there you go. In only a few seconds, you have your Streamlit app up and running. So why don't we split the screen so that we could have the code on one end and the app on the other end. I'm going to take the app out. I'm going to put it to the right and this one to the left. So let's start by modifying the name of the app, shall we? So we're calling it machine learning app, and we're giving it an emoji. And instead of hello world, we're gonna say, using the st-info, this is a machine learning app. Or how about this app builds a machine learning model. And then we're gonna save it. Let's see how fast it reflects in the updated app here. All right, so almost instantaneously, you get to see the updates in your app here. And so worthy to note, you could share this URL, it's public. You can share it with your friends around the world. Okay, and so next step is we want to get the dataset in. So this is the penguins dataset. I have already cleaned the data. And these are the columns of the dataset. So what we want to do is we want to predict the species of the penguins. And we're going to use everything else as the input. So when we're constructing a machine learning model, we want to use X as, kind of like the input data. And we're going to use Y, which is like the species here, as like the output data. So given input data, we want to predict the output data. So if it's an equation, you could think of the species as being Y equals to a function of X. And X would means X1, X2, X3, X4, X5, X6. Okay? So given the input values here, we're going to predict the species. So that's the machine learning equation that we'll essentially do here. So why don't we click on the raw link here, and then it's essentially a CSV file. I'm copying the URL here. So the first column here is species, which we're going to use as the output, and the remainder here are the inputs. So we'll start by reading in the data. So we're going to import pandas as PD, and then we're going to read it in. Read CSV function, and let's just say df. So it'll display the data frame in the app. All right, and so this is the data frame, which was read from the GitHub repository. So why don't I, for simplicity, we're going to use the expander. We're going to have this expander called data. And then, so we're going to call this the, we're going to give it header, subheader, or just some simple text and right. And I'm going to call it, raw data. We're going to make it bold with the double asterisk, which is in Markdown language. Let's save it first. Let's have a look how it looks like. Just in here, in the data expander box. So we click on it and we get to see the raw data. And we're going to have the right, and then we're going to have the next one. Let's have the x variables. So we're going to call it the f, and then we're going to have the f, and then we're going to we're going to delete, or we're going to drop the species column. Drop species, and then axis equals to 1. And then we're going to show. Then we're going to have right. And then we're going to have the y variable. Y equals to, we could just have the f species. And then we're going to show y. Save it. It should be reflected in here. All right, so this is our original raw data. And if we scroll down, we're going to have our x data here, which is excluding the species column. And it has everything else here. And the y variable is the species column. So it has 100 and we have a couple hundred penguins data in here. So yeah, we're good to go now. Why don't we, let's see, what if we add some data visualization to it? Let's go to the Streamlit documentation. So you could head over to docs.streamlit.io. And we're gonna have some chart elements in here. Not chat, but charts, okay? Chart elements. Let's see which one we want to have. How about a simple scatter chart? Let's have a look at the example here. So we just need to do a subset of the data with the columns. So let's see. Let's head over back here. It's just see the scatter chart. Okay. Let's have a look in the information here. So we put in the data. We could specify the x and y, and also the x label, y label. Okay, and we also could specify the color in here as well. Okay, let's do that. So let's create another expander. Let's call it data visualization. We're going to use st scatter charts. We're going to read in the df. We could just say df equals to data equals to df. And then we want to have x-axis. Let's see. What about the build length and the build depth? How about that? Or how about the build length and the body mass? Let me just copy everything here first. Put it here as a comment so that I could see it. So in the x-axis, why don't we specify it to be build length? And then y-axis, we're gonna have it the body mass. And now we'll delete this. And then color, let's do the species. We'll color it by the species. Okay, let's see. Alrighty, so that's our data visualization here. So we're coloring it by the 3 different species of the penguins. So the dark blue here is Adelie, light blue is chinstrap, and then we have in red the Gentoo penguins. And then we could collapse it here as well. Okay, so you could, add other visualization as you like. And so we have already did some data preparation. We have already split the data into X and Y. Why don't we proceed further? So we're going to do some additional data prep. Okay, so why don't we allow the user to input the various features as interactive input widgets, and then we're going to create a data frame out of that. Yeah, let's do that. So we're going to have on the sidebar several widgets. Same, we're going to have sidebar, header, input features. Let's have a look. All right, input features. Then we're gonna have we have the island. Why don't we take all of this and then we'll paste it here. We have the island, so we're gonna go ahead and say island equals to a select box. So we're gonna have like a drop-down menu. Search for it, select box, display select widget. So essentially a select box is kind of like this. So we're gonna have st.select box, and then we're going to call it island. Then let's see, we're gonna have the names of the islands. So we have Torgerson, we have Bisco, we have Dream. So there are essentially 3 islands here, right? 3 islands. So let's type it in here. So we're gonna have Bisco, Dream, and Torgerson. And then the next one will be gender. Let's call it gender. Select box. And then we have male, female. Then next we have, so we have already did that. So we're gonna have billing. We're gonna copy paste it here. st.slider. So let me show you the slider. You could go here and find the input widgets. It's st.slider. Scroll down, and so you could just give it a string here, and then the range, and then the default value. Okay, st.slider, and the name is going to be bill length in millimeter. And then we're going to put in the minimum values, and also the maximum value, and also the mean value. So I have already did the calculation, and the minimum value is 32.1, 59.6 for the maximum value, and 43.9 for the average value. So let's save it for now. Let's see how it updates in the app. Okay. Very good. Number updates in here. Let's continue with the sliders. And then the next part is build that SC slider. We have to build depth, we have millimeter, then we're gonna have 13.1, 21.5, and then 17.2. We're gonna have flipper length, st slider, flipper length, it's gonna be millimeter, and then we're gonna have 172.0, 231.0, and 201.0. Lastly, for the body mass, it's going to be st slider, then we call it body mass, and then G for the grams, 2700, 6300, and then 4207. Let's have it here. Right, very good. It's already updated. So we're going to piece together all of these input widgets into a data frame. Let me delete that first. So we're going to create a data frame. Create a data frame for the input features. So we're going to create firstly a dictionary called data here, and then we're going to have island. Then we're going to have the variable name island. Let me make it in the same order as the original data. So we have gender at the end here. So we have build length. Next. It's just a repeat of the name. Build depth. And we have flipper length. Body mass, then we have gender, and then we're going to do input data frame equals to pd.data frame, and then we're going to have it as the name of the dictionary in here, index 0. So let's do this and display the data frame for the input features. Oops, let's have a look at what is wrong. Oh, okay, it's not yet ready. So before looking at the input data frame, we're first going to combine it. We're going to combine it to the original data set first. So let's do the input penguins, and then pd.concat, and then we're going to combine the input features with the penguins, which is the y. Nav axis equals to 0. Let's see. Input penguins. Oh, okay. I think it's not comma. It's actually should be colon. Sorry about that. All right, there you go. So let's see, before we have the penguins, let's have a look at the input df. All right, so this is the input data frame. So when the user, selects a different value in here, it will be reflected directly in the generated data frame, as you can see here. All right, so it works now. Let's have a look at the input penguins when we combine it together with the original data set. So it's going to be useful for the data type later on. So our input is right here in the first line. Okay, let me move this into maybe data. We'll put it into an expander. Inputs, features, and then we'll show both of the data frame in here. Right, and then we're gonna have the input features. How would we say single species? Input penguin? Yeah, let's do a input penguin. And then the other one would be the combined data, because we were combining the input penguin data with the original penguins data. Combine penguins data. And this in here. Oops, I need to add the colon. Save it. And it's in here, input features. Alrighty. So what we want to do next is we're gonna encode or prepare the data set further, because island and gender are strings or text. We're gonna have to encode it. So we're gonna do encode equals to island, gender. So both of these will be encoded. We're gonna have df penguins pd get dummies. So we're gonna have a look what this one would do. And then we're gonna display it so that we could all see what it would do here. Why don't we just get the first one? Show the first. And for the penguins to be... Oh, okay, I think our data set is called a different name, is it? Let's see. So the gender is called sex here. And input feature, we have gender, and then we have sex. Okay, I think we'll just need to call it the same name. Hopefully this works. Okay, it works now. It was a column name mismatch. So let's have a look at the... We're going to use only the first row. We're going to call it here. This will allow us to show only the first row. Let's see. At the bottom here. All right, so it does the following. With the get dummies, it will, convert each of the value in the column into a unique column name. So we have here, instead of having the column island and then the value of Bisco, is combining island and Bisco together, and then it's giving it a value of either 0 or 1. As you're going to see here, if it has a check, then it's a 1. If it doesn't, it's a 0. So it's combining the column name and the value name into a new column name. And therefore, the two variables that we have, island and sex, would then become island Bisco, island Dream, island Torgerson, etc. So we have 5 additional columns, which was expanded from the original 2. So this is the original, this is the input feature of the penguins. And we're going to do the same for the species. Let me do that. Let's collapse this for now. Input features, okay. We're going to put the encoding right here, so that it will be into the we're going to put it into the input features, encoded input penguin. We're going to call it input row, and let's put it here. Right here, encode it. Okay. Now we're going to add some votes here as well. So we're going to also prepare the for the Y, let's see, prepare Y. How do we say? Encode Y. Here we have encode X. Okay. We don't actually need to put it inside sidebar. So, yeah, you'll notice that we're gonna build this on the fly so that you also get the thought process of building a Streamlit app as well. So you're gonna see that sometimes we encounter errors, then we find out what's the cause of the error so that we could debug it. So yeah, so that's in a practical setting. The most essential skill is debugging, and as the process of doing so, you'll also learn how to create the app, with less error in the future. So encode Y, we're going to create a mapper variable. We'll call it the target mapper, and then we're going to have a deli as, oh, I have to make it colon. Before I used a colon. So that's giving it an error. Chin strap, and then we're giving it value of 1. For gen 2, we're giving it a value of 2. Then we're going to define a custom function called target encode. Target is like the y value, which is the species. So the input value, and then we're going to return the target member value. So previously we had the y value here. So why don't I call it y raw and x raw. And at x here, we're gonna use x raw. It's the raw data sets. Let's save it, make sure everything runs perfectly for now. It doesn't spit out an error. Okay, we're good to go. Yep, we're good to go. Just to make sure. Let's continue with our encoding of y. So the x raw is the penguins data set. Now we're going to encode. So we're going to do y equals to the y raw dot apply, and then we're going to have target encode function. Let's see if that works. And then we're going to print out y. Let's do it side by side with the original y raw. So let's have a look. Yep, so originally it's a deli, then it becomes 0. Then when it becomes gen 2, it would be a value of 2. That's correct. And then finally, the chin strap will have a value of 1. Okay, so that's according to what we have in the target mapper. Very good. Input features. Okay. Let me take it out of the input features. I mean, input features should be input features, right? So I'll take the last part here out. I'll move this to be following the sidebar. This should be the input features, not data prep. Input features. Then our data prep will be here, data preparation, because we're encoding the data. So we're going to create a new expander, or calling it data preparation. Encoding. How about we call it encoded X? No, encoded, yeah, input penguin, which will be X, because we're going to strip out the, I mean, we don't already have the Y value for the input penguin. So it's technically a one row of the X, okay? It's the input X, and then we're going to have the Y. So we're calling it encoded Y. Encoded X of the input penguin. Yeah, let's call it that. And then we have encoded Y. And then the encoded Y will be Y. Now delete that there. And that's encoded X. Okay, good. Let's save it. Okay, let me add the colon. Add the colon here. Should be good. Yep, data preparation is in here. Encoded Y and then our encoded X. Okay, we're good to go because the column value and the value are combined into a binary. Alrighty. Now we're good to go and we're going to train the model. So we're going to import the random forest classifier. We're going to use that for the classifications. So on the scikit-learn page here, we'll go ahead and click on random forest. And since we're going to use the random forest classifier, we're just going to go ahead and copy this line here. And if you need information about the method here, there's more information displayed here. And we could also play around with the various input parameters, like the number of estimators and the max step here as well. So maybe another video. Let me know in the comment section if you like that. So let's add it in. Let's import the random forest classifier. Go ahead and build the model. Let's call it model training. We're going to train the model. Model training. So we're going to call it CLF, and then we're going to have the random forest classifier initialize first. Then we're going to train it. We're going to use the fit function to train it. And we're going to use the X and the Y. But then we need the X here, we're going to have to be we're going to use X raw. Train it, and then once we train it, we're going to apply the model. Let's call this, let's call it model training and inference. And then this will be model. We're going to train the ML model. And then we're going to apply the model, the train model, which is in CLF. Apply model to make predictions. So we're going to use prediction equals, which is the predicted value. We're going to have CLF dot predict. Then we're going to have input row. Input row is the input feature. Input row is right here, the encoded penguin data of the single row. Then after making prediction, we're going to add the probability. We're going to take the probability of the prediction, like whether it's predicted to be 70% Adeli or so. Or say predict proba function from the scikit-learn. And then we're going to put the input row as the input parameter. Yeah, let's do it. Up to now, let's see what is the result. So you're going to see it's running, it's building the model. Okay, it's giving us an error. Let's see, cannot convert string to float Torgerson. Okay, so I guess we need to have the encoded version as well. Okay, we need to use the encoded version. Sorry about that. So the encoded version should be DF penguins. Show it again. Okay, we need to take out the first row because it had the input feature. Let me do that. So we had X raw, and then we have the penguins. So for consistency, we're going to call it right here. We're going to call it. We're going to have DF penguins. Then we're going to ignore the first row. And then we're going to use everything else. Oh no. Yeah, everything else after the first row. We're going to use only the first row. The input row. Okay. Then X, we're going to use only the second row and beyond. So calling it back to X. Should work now. Alright. It works. And now we have 3 columns. So 0, 1, 2, right? 2 is Gen 2, 1 is we have to have a look here. 1 is chin strap, 0 is a deli. So the probability of the input features here being a deli is 76%. That's our prediction proba. Why don't we can we do this? Columns, deli, and then chin strap, and then Gen 2. Would that work? Might have been just column. Okay, it's probably not a. Okay, so we're gonna use a map then. We're gonna say df dot. We're gonna say prediction proba. We're gonna have it renamed. We're gonna have columns equals. That works. Let's say 0 to be 0 is a deli. That work? Oh, it's a numpy array. Okay, well, first I have to convert it into a. We'll give the name df, and then we're say df data frame prediction proba. Let's see if that works. Will it give out an error? No error. Okay, so it was a numpy array. That's why it didn't work. How about the previous version that I did? Column. Would column work? A deli, chin strap, Gen 2. It seems to work. It's not giving out an error. The prediction proba. Oh. How about columns? Oh, okay, I think I know. It's not. It doesn't have a column name. That's why. If it does have a column name, then it would have worked. So we're probably gonna have to do this way then. Okay, there we go. Oh. Oh, or did it work previously? Let's see. And temporarily it did work. Let's try again. It should be like that. All right, it worked. Finally, it worked. All right, very good. So we're gonna say let's hide it first. We're gonna say we're gonna display predicted species, and we're gonna create a subheader called predicted species. Say prediction proba is 0.69. We're gonna say penguins species equals to numpy array. deli chinstrap gen2. We're going to use stSuccess. We're going to have a string. Then we're going to put in penguin species. And then we're going to have the prediction value. And then that should give us the name of the penguin species. Okay, we need to import numpy first. Sorry about that. Import numpy as np. All right, and we got a deli. So this is matching the probability data frame here. So let me put this below. Okay. All right. It's looking good. I think I could beautify it some more. We could definitely add a, let me see. I think we could add the progress column. Let's head over to the Streamlit documentation. Data elements, column config. Let me expand this a bit. Yeah, I think we could add this progress column. It will look a lot better. So we could use the column config option. So I'm going to use st.dataframe. We're going to add it right here. I'm going to use st.dataframe. And then I'm going to put this in here. Then I'm going to use the column config equals, we're going to call it deli st column config progress column, opening it up, closing it. We're calling it deli format. We're going to have %f for floats. Width would be medium. Minimum value, we'll have it as 0. Max value of 1 because it's the probability. We're going to change it to chinstrap. We're going to make this chinstrap. Chinstrap, this will be gen2, gen2. And then we're gonna hide the index. Should be okay. Okay, I think I forgot a comma. Yep. Forgot a comma here. line number 98. 98. Okay, another column missed here. Oh, okay, I forgot the column in the original one. All right, should work. All right, it looks pretty good now. Let's see. 76% Adeli, okay, and the final output is Adeli. We have only 8% as Chinstrap, 16% as Gen2. Let's modify the input here to be Dream. So you see that when we modify, let me expand this app. When we modify the value, the probability changes, just by the origin of the island, like where did the penguin came from, which island, it modified the probability. So if the penguin is coming from the Dream Island, then there's a probability of it becoming Chinstrap much higher. Versus when it's coming from Bisco, it's like 70%. And Delhi is like 88 for the Torgerson Island. Right, changing the body mass to be smaller, then the probability of Delhi became much more. Or build depth, and also the build length. So it's very interactive, and you could play around with the input features here, which will allow you to, predict the penguin species. So if you were to take your Streamlit app to the islands here, you take out a ruler, you measure the various features of the penguins, you'll be able to predict which species they are. And so, yeah, this is very handy. And you could also repurpose this app to other dataset as well, apply the same principles mentioned in this tutorial video. And yeah, you'll be able to see already in this video that there were occasions when errors or problems occurred. We were able to debug the error because of some typo. And yeah, that's like one of the most important thing is being able to look at the output, figure out what is wrong with the app, which is the origin of the error, and then, try to fix that, see if it works, read the error message again. You'll be able to see that the error message will also be printed out in the log here. This is like the command line output log that you could read through. And you could also download it to your local computer as well by clicking on the download log. And if there's a need to reboot the app, you could click here on reboot app. And yeah, as you can see, we're building the app feature by feature, line by line. And whenever we wanted to add a new feature, we just go to the documentation. We figure out how it's being used from the example, and then we adapt it to our code and the use case of our app here. And so, yeah, if you found this video helpful, please support the channel by dropping a like, give it a thumbs up, subscribing to the channel, turning on notifications, and yeah, let me know in the comments section down below which other Streamlit apps that you want to see me build. And as always, happy Streamliting.